Welcome to qnawire.
In this question, we want to solve the following equation. Psi of x is equals to 0.01 times psi of 0. So we must find x such that it is 1% of the value of the wave function at one of the walls. And we have chosen the left wall for simplicity. So we already know what is the formula for the wave function in region 1. In region 1, the wave function is given by this equation. So we can rewrite this condition as follows. C times E G times x is equals to 0.01 times C. The C simplifies, and we get G times x is equals to the logarithm of 10 to the minus 2. So x is equals to minus 2 log of 10 divided by g. Now we have to find out what is the value of g to finish this question. To calculate the value of g, we must first calculate what is the value of the ground state energy. And this can be done as follows. The ground state energy, U1, is given by the well-known formula, which is 1 squared, that is equals to 1, times h squared divided by 8m L squared. This formula can be valid even in this case if the value that we get from U1 is very small compared to the value of U0. So we have to calculate U1 and check if this condition is fulfilled. H squared is equals to 6.63 times 10 to minus 34 squared, and this is divided by 8 times the mass, which is 9.11, times 10 to minus 31, times L squared. L is equals to 0.16 times 10 to the minus 9 because of the nano prefix, and this will give us the energy. But this will give us an energy that is measured in joules. To compare to the electron volt energy of U0, we must convert the energy U1 from joules to electron volts. We can do that by dividing the result by the electron charge. So we divide this result by 1.6 times 10 to minus 19. And at the end, we get the ground state energy of approximately 14.73 electron volts. And this is much smaller than 2 kilo electron volts. So we can use this value for the ground state energy, which is a valid approximation. Now that we know the value of the energy, we can calculate the value of G and plug in this expression to finish the question. Now let us evaluate G. G is equals to the square root of 2 times the mass, which is 9.11 times 10 to minus 31, times U0, which is 2 times 10 to the third, because we have a kilo, times electron volts. But this should be an energy that is measured in joules, so we have to convert it from electron volts to joules. We can do that by multiplying this energy by the electron charge. So 2 times 10 to the third times 1.6 times 10 to minus 19. And this is minus the energy that we have just calculated, which is 14.73 times 1.6 times 10 to minus 19. We are again converting the energy to joules. Take the square root and then divide it by h bar, which is approximately 1.055 times 10 to minus 34. We then finish the question by plugging in this complicated calculation in the expression for x. By doing that, we get the following. X is equals to minus 2 times the logarithm of 10 times 1.055 times 10 to minus 34, and this is divided by the square root of 2 times 9.11 times 10 to minus 31 times 2 times 10 to the third minus 14.73 times 1.6 times 10 to minus 19. Then we get x is approximately minus 2 times 10 to minus 11 meters, finishing our question.